In this section, we want to briefly introduce the idea of an antiderivative. An antiderivative is what you get if you try to undo the taking of a derivative. So if y is equal to x squared, then dy dx is 2x. But what if I told you dy dx equals 2x? Could you undo that derivative process and figure out that the father function, the function I started with, was f of x? So a function, capital F of x, is an antiderivative of little f of x if the derivative of capital F equals little f for all the x's in the domain. The process of finding this function is called antidifferentiation, or finding an antiderivative. So take a look at that first problem on your handout. It's common to use this capital F notation to stand for an antiderivative of a function, little f, that's the derivative. So here we've been asked to find any antiderivative of little f of x equals sine of x. So basically the question we've been asked to answer is, what should I have taken the derivative of if I wanted the answer to be sine of x? Well, we can take a guess. It's your job to be so familiar with derivatives that you can sort of run through these possibilities in your mind pretty quickly. We know that if we take the derivative of cosine of x, we'll get sine of x. And it's, negative sine of x. And it's our job to extrapolate from there and recognize that if we had taken the derivative of negative cosine of x, we'd get sine of x as the answer. So our answer to this question, any antiderivative, the easiest antiderivative of sine of x to find, I'm going to call it capital F of x, is the opposite of cosine of x. Because if I take the derivative of negative cosine of x, I get little f of x, which is sine of x. But here's the problem. If I had asked you to take the derivative of f of x, which was 2x,